Hello everyone, we are discussing Faraday's laws and so far you know that induced EMF is minus of d phi by dt, and negative sign it represents Lenz's law, which means induced EMF is going to oppose cause of its own production. This is something which we have already done. Let's take a few questions so that we can feel everything. Let's say we have a U-shaped wire and resistance of the wire is R. And on this wire, another straight rod of length L starts moving in this direction with initial velocity u. Mass of the wire is m and there is no friction present between this straight rod and the U-shaped wire. This is the U-shaped wire. There is a rod and the rod is sliding in a horizontal plane. So remember, everything is in the horizontal plane. This is your U-shaped wire, that's your rod, and rod is sliding like this with initial velocity u. Its mass is m, and it's given that magnetic field is present inwards and is uniform. If it's not uniform, then we'll have to use integration. So right now it is uniform. First of all, you've got 20 seconds time. Tell me what will be the direction of current in this closed circuit because of this rod moving with velocity u. Direction of current, you will answer in terms of clockwise or anti-clockwise. Current is going to flow clock or this is going to flow anti-clock. Answer this, note down this much. This is the initial moment, that is t equals to 0. Right now, rod is moving with initial velocity u. What is the direction of current? Clock or anti-clock? Only one person has responded so far. Rod is moving in this direction. We can find out direction of induced EMF with the help of FBI. with the concept of STP, but we are right now interested in Lenz's law. How can we take advantage of Lenz's law in deciding direction of current? Magnetic field is inwards, and as this rod moves in this direction, there are two ways we'll use the concept of Lenz's law. Now, as this rod moves in this direction, Lenz says that cause should be opposed. What is the cause of EMF? Velocity. It should be opposed. It will be opposed by a force which is acting in this direction. Now just let me have an idea whether you understand the logic behind cause and all. If I produce the same setup, which in itself is an objective question. If I produce the same setup, rod is moving in this direction with you, same thing, but instead of having magnetic field inwards, if I have a magnetic field which is pointing out, if we have a magnetic field which is pointing in, then the force is coming in this direction. So if I say that magnetic field is pointing towards you, direction of force will be on this rod, left or right. Mention this in the comment box. If in this figure it is left, magnetic field is in, then what do you think is the direction of force on this rod, to the left or to the right? Mention this in the comment box. Good. It doesn't matter what is the direction of magnetic field. Lenz's law, it says that cause should be opposed. That means even in this direction, even in this figure, force will be to the left, opposing the cause. Now, this is one way of deciding direction of force. Cause is being opposed. Write down this as a statement. Since cause of induced EMF is velocity of the rod, according to Lenz, this cause should be opposed. According to Lenz, this cause should be opposed. And therefore, irrespective of direction of magnetic field, force acting on the rod in both figures, has same direction. Now, once we have decided force, we have a rod. This rod is present in this magnetic field, and I asked you what is the direction of current. You will use FBI. B is this finger which is pointing in, left hand, B. I is something I need. This is force, and I know the direction of force. Force is this way. That's how you're holding your hand. This is B, this is F. So B is in, force is this way. You can see that current is up. Current which is flowing in the rod is in this direction. This is your I. That means current is flowing anti-clockwise. Direction of current in the circuit is what? Anti-clockwise. Now, what is the direction of current in this figure? Find out and answer this in the comment box fast. Is it? We have same force. Does it mean that direction of current is also same? Is it clockwise or is it anti-clockwise in the second figure? Good. Direction of force is same, but you can see that direction of magnetic field is different. In this figure, magnetic field is pointing towards you. Force is this way. That's the force. This way. That's magnetic field. This is current. Current is coming down. So current is flowing like this. That's the current. Which means this. That is clockwise. So only you can decide the direction of force very easily, which is oppose the cause. Direction of current, you have to use FBI, and you can see that since magnetic field, its direction is opposite in that figure, you have an opposite sense of current. Now, we have used one logic coming from Lenz's law in deciding direction of induced EMF or induced current in this figure. Now let's use the second logic. The second logic is, as this rod moves in this direction, magnetic field lines which are pointing inwards, this number will continuously increase. So you will say that flux is increasing. When this rod moves to this place, more number of magnetic field lines are now present inside the closed loop. Very easy for you to visualize, nothing special. As the rod moves, the whole thing, its area increases. Area increases means more number of magnetic field lines are passing that area. So you are saying that flux is increasing. Now you are saying that Faraday says induced EMF develops if flux changes. Flux is changing, is increasing. Lenz says that induced EMF opposes cause of its production. So what is the cause? Cause is increase in flux. So this time round, this increase in flux is the cause. We are developing second method. In first method, this was the cause. Now, this is the cause, which is increase in flux. although you know that both are same thing. Because of this only, rod is moving this way and therefore flux is increasing. But we can find direction of induced EMF easily using this second method. So as flux increases, which is the cause, Lenz says cause must be opposed. Cause must be opposed means what? You have to somehow decrease the magnetic flux. It is increasing and you have to oppose it. That means you need to decrease this magnetic flux. Now, how do you decrease magnetic flux? If you can produce a magnetic field which opposes this magnetic field, then total magnetic field will decrease. Listen again. Direction of current should be such that it produces a magnetic field which is opposite to this magnetic field. These two magnetic fields will cancel each other, not completely, but overall magnetic field as it decreases. Magnetic field decreases means number of magnetic field lines is decreasing. That means you have started decreasing what? Flux. So current should be such that it produces a magnetic field which is opposite to this. It only means you are opposing the cause. Now how do you produce a magnetic field which is opposite to this? Right hand, thumb, it gives the direction of current, it gives the direction of magnetic field, and fingers, when you curl them, when you fold them like this, that is the direction of current. This is coming from magnetic field of a circular ring, closed loop. So if you want a magnetic field which is out, your current should be anti-clockwise. So without using FBI, by just looking at the area, since it's increasing, you need to oppose this, hold your right hand, and you immediately get what? Direction of induced EMF or induced current. Tell me, do you understand the second method? Yes or no? Write down fast in the comment box and practice this thing over here. The second method, do you understand it? And verify this thing in the second figure. So here, rod is moving in this direction. Again, flux is increasing. The flux is increasing, you have to decrease it, but this time magnetic field is pointing towards you. Magnetic field is towards you. As the rod moves, more number of magnetic field lines pointing towards you are present, and you need to decrease this. That means you need to produce a magnetic field which is opposite to this magnetic field. Hold your thumb inside them. Thumb gives you the direction of magnetic field. This is pointing in. That's the current. In just 1 second you can find direction of current using the approach of flux. That's the advantage of Lenz's law. It gives us direction of current very easily. In both cases, flux is increasing. In this figure, field lines are coming towards you, and therefore induced current should be such that its magnetic field is opposite to the magnetic field which is already present. Write down this as a second method for deciding direction of current. as the rod moves to the right, area of the loop increases, which increases flux. And therefore direction of induced current should be such that it produces a magnetic field which is opposite to that already present. Now, that's how you decide direction. We'll also see a few more examples, but before that, you can expect something like this in school, board, JEE and NEET. Right here, when this is moving with you, this current is I. Find out I and find out F. Find out these two things, I and F, acting on the rod, force, current flowing in the rod, I. Find out these two things. You've got 1 minute's time. Let's see if you can find it. Not a single response. Let me give you a hint. You know that rod is moving with you. Its length is known. The magnetic field in which this rod is moving, that is known. It will give you what? Magnitude of induced EMF. this rod is going to behave like a battery. You know how to find the EMF. Once EMF is known, you can find the current. And then, if you know current in a wire, which is present in some magnetic field, you can find force on the wire also. That's the hint. And even after giving this much hint, only one person could produce the answer. And it's such a shame that even after being told, if you have velocity, length, magnetic field, all three perpendicular, then magnitude of induced EMF is simply BL into V, and that velocity is what U. So this figure is equivalent to this. We have found the direction of induced EMF. This is the magnitude. And I'm asking you what is current, and only one person could produce the answer. I is E upon R. This is BLV divided by R. So let me just tell you this. Those of you who could not answer even this simple thing, just coming from 10th, V upon R, Ohm's law. If you cannot answer even this, then it means you need a lot of hard work. You've got the study package, you've got video lectures and all. Watch all the classes which you have seen if you want to watch them again. Do solve questions, make sure you solve at least 100 questions from this, and then only it will increase your grip over this. Such a simple thing. If you find it difficult, then you will have to follow what I am saying. So now I've got the current which is coming BL and velocity is U. U divided by R. Now find me force which is acting on the rod. Get me the magnitude of force and write down this in the comment box. That's the current. Good. At least 2-3 people started responding. If we have a rod which is moving, which is having a current, then we know force acting on it. The formula is what? B I L sine theta. BIL sine theta. So we need this force. Magnetic field is what? B. Current I. BLU upon R. BLU divided by R. This is current multiplied by L, length of the wire, which is L. Length of wire, current, magnetic field, theta. What is theta? Theta is angle between magnetic field and length vector. What is the angle between magnetic field, which is pointing in, and length vector? 90, sine 90. And therefore this F is coming B square L square U divided by R. This is force. They are two very easy objective questions which you can expect in any competitive examination. B square L square U divided by R. Note down this. Now note down another question which will clear the concept of Lenz's law. If you remember, I will discuss this thing. Let me ask the question first. Write down the question. You can see that this rod is under this force. Force is opposing this velocity, and therefore this velocity will keep on decreasing. So after some time, this rod will come to rest. This force is decreasing the velocity, and ultimately this rod is going to come at rest. If somebody is interested, they can find the time when the rod comes at rest. If you are interested in JEE advanced type of thing. You can also find after moving what distance this rod will come to rest. Mass is given, but remember I told you for JEE advanced. For NEET and JEE and even for board, I'm asking you much easier question. You can see that a current is flowing in the resistor, and which produces what? Heat. This is coming from power, which we have done in electric circuit. Because of the current, heat is coming out. And the current is present as long as this rod is moving. Rod is moving, which is producing what? EMF, which is creating the current, which is producing heat. So when the rod stops finally, EMF becomes zero, current becomes zero, and no longer heat is coming out. So the question is, starting from this, when it started moving with you, and finally when it comes to rest, what amount of heat dissipation takes place in the resistor? Write down the question. Find out total heat dissipation in the resistor. Total heat dissipation in the resistor. And remember the logic which I have given you. Since rod is moving, it is producing what? An EMF. And that EMF is creating what? Current. When current flows, heat comes out. So finally when rod stops, there will be no EMF, there will be no current. So by that time, when finally it stops, what amount of heat dissipation took place in the circuit? Well, the hint is that you can write the answer in just 2 seconds. This is the hint. You can write the answer. What time it takes for you to think, I don't know, but you can write the answer in just 2 seconds. This is the hint. Second part of the hint. Now, I don't expect a correct answer from you. And by the way, there is no response from your side also. So let me give you another hint. When we discussed Lenz's law, I told you that Lenz's law is based on conservation of energy. Now this is the hint. Lenz's law is based on conservation of energy. And that will be clear from this example. But it is a hint for you. Conservation of energy. To tell me what amount of heat is coming out. You can answer this. There is enough hint present now. Conservation of energy. It started from this, finally its velocity becomes 0. Finally. T0, initial moment. Initially, this rod of mass m is moving with velocity u, and therefore initially its kinetic energy is half mu square. We have a rod of mass m which is moving with velocity u. So you're saying that initially this rod has a kinetic energy of half mu square, and finally its kinetic energy is 0. It's not moving. So where has this energy gone? It was moving with half mu square. It's not moving at all. There is no friction present. If friction were present, then because of friction some heat will also develop. But question says there is no friction. Heat can only come out from this. Heat is what? Heat is another energy. So this kinetic energy converts itself into electrical energy. Electrical energy in turn converts itself into what? Heat energy. Conservation of energy says you started with what? Half mu square. Ultimately you don't have any kinetic energy, and therefore this loss in kinetic energy will appear as what? Heat, which is half mu square. In just 2 seconds, you can write half mu square. This is the answer. And therefore, it's a very good question. Half mu square is coming because of what? Conservation of energy. Write down everything and then we'll write a few statements. Just tell me, do you understand this origin of half mu square? Yes or no? Write down the statement. When the rod moves, force acting on it decreases its kinetic energy. Force acting on it decreases its kinetic energy. When rod finally stops, this loss in kinetic energy appears in the form of heat. This loss in kinetic energy appears in the form of heat. Which is nothing but conversion of kinetic energy into electrical energy and finally into heat energy. Inside the bracket, conservation of energy. Now, when we say that Lenz's law is based on energy conservation, what is the reason behind this? Let's understand this part also. Lenz says that whatever is the cause, induced EMF will oppose it. Suppose, imagine a situation that rod is moving in this direction and force also develops in this direction. Current is flowing such that downwards that it produces a force in this direction. If something like this happens, then what is wrong with this? This force will increase the velocity. So you have a rod which starts moving with you, it produces an EMF which creates a current, and the current is creating a force like this, and the force is supporting the velocity. That means it is increasing its kinetic energy. So you are increasing kinetic energy of the rod. You are increasing kinetic energy of the rod, at the same time you are getting what? Heat. Imagine you have a bulb, a light bulb over here. So you are getting what? Light energy through the bulb. At the same time, this rod is increasing its velocity. As it increases its velocity, more EMF is generated. More EMF is generated means more current is being produced, more light is coming out. So you are getting all this energy out of nothing. You had a rod, you moved it, and then just leave it. There is no need for you to work. There is no need of any power plant or anything like that. You simply had a rod, you started moving it. Now this thing is creating energy on its own. Something which is not possible. This is the violation of what? Energy conservation. And therefore, you cannot have a force which is in this direction. The moment the rod moves, you know that as the rod moves, this rod also has electrons. So the moment rod moves, those electrons are moving in the presence of magnetic field. They are under a force, and because of that force they start moving, which produces what? Current. So what happened? The moment you start moving this rod, electrons also start moving in this direction, developing a current. Basically, electrons are moving in the opposite direction. They are negatively charged. So the moment you start moving the rod, electrons also start moving. That means what? Part of the energy is being shared by electrons now. So the energy coming from half mu square is being transferred to what? The current part, to the kinetic energy of moving electrons. So you are sharing, the electrons are sharing energy of the rod, and for that you have to decrease you. Your sharing means you had 100 rupees, you share 20 rupees with someone, now you are left with only 80 rupees. So since you are left with 80 rupees, you now have less velocity. Or do you have less velocity? The only way is have a force which opposes you. That is what Lenz's law. I hope it's clear the way Lenz's law works. There is a homework for those who are looking for mainly JEE. Same setup. This is the rod also has some resistance. Is moving with you and magnetic field. This is the homework question, not for everyone, although it's not difficult. In this figure, resistance was only present in the circuit. There was no resistance present with the rod. But this time, rod also has the resistance R. The question is, what amount of heat generation takes place in R, that is the U-shaped rails, and what amount of heat generation takes place in the rod? Small r for resistance of the rod. This is for those who are interested in these things. Note down this question. There are two rods moving with velocities v and 2v. Magnetic field is inwards in the entire region. These are two horizontal rails. And on those two horizontal rails there are two rods which are moving with v and 2v. Resistance of both rods is R. You can take the resistance as same, they are identical rods moving with different velocities v and 2v. First, tell me the direction of current which is present, clockwise or anti-clockwise, and then give me the direction, give me that current also. And finally, you need to write force with proper direction on both rods. Right now, in the comment box, give me the direction of current, like clockwise or anti-clockwise. And then, second part, you will write the current. And third part, you will write force on these rods. Step by step, answer these questions. And if you are active enough, you can answer easily these things. Let's find out direction of current. So what you should do, find out whether flux is increasing or decreasing. That is a deciding factor. How do you find whether flux is increasing or decreasing? Look at the area. How do you decide what happens to area? Look at the velocities. So you have a rod moving with V, which is being followed by another rod moving in the same direction with 2V. So I hope it's clear that the area enclosed will decrease. Area of the loop is going to decrease. This is a slow moving rod, and therefore area of the closed loop is going to decrease. As area decreases, number of magnetic field lines, that number will also decrease. So you know that phi is also decreasing. If phi is decreasing, then induced EMF should produce a current which tries to increase this decreasing flux, opposing cause. flux is decreasing, induced current should be such that it tries to increase it. If you want to increase flux, then you need to support this magnetic field. How do you support this magnetic field? By producing a magnetic field which is also inverse. Inverse means hold your thumb in, curl, look at the direction, clock. The direction of current is coming what? Clockwise. I hope it is clear. Flux is decreasing, you're trying to increase it. To increase the flux, you need to support this magnetic field. How do you support a magnetic field which is pointing in? By producing another field which is also inwards. In, hold your thumb in, curl, so you got the answer clockwise. And everybody answered anti-clockwise. There are 4 or 5 responses, all were anti-clock. So now is it clear? Direction of current, is it clear? Yes or no? Now, the moment you found the direction, let's find out direction of induced EMF. Now, there are 2 rods, and these rods are going to behave like 2 different batteries. 2 different batteries means this setup is going to look like this. Look here. The time being, I'm removing these resistance. I just want to develop the sense of EMF. You can have several variations. This, let's say option A. Then this, option B, then this, and then this. There are 2 rods and therefore there are 2 batteries. Which option is correct? A, B, C, D. Write down this in the comment box and you can expect something like this in your objective examinations. I hope you can see the polarities. Look here. We already know the direction of overall current, which is what? Clock. Overall current is clockwise. If you have an option like C, then C, you can see these batteries are going to produce a current in this form. This and this, they are supporting each other, and therefore you're getting what? This type of current. But you already know the direction of current, and therefore this is something which is not possible at all. Not at all. Now regarding D, B and A, they can produce different senses depending on the strength, and therefore let's go for the strength of EMF now. This one is moving with V, this one is moving with 2V. To save time, I'm saying that its EMF is therefore E, but its EMF is 2E. This is moving with V, and therefore EMF in this rod will be what? BVL. This rod is moving with 2V, and therefore EMF in this rod will be B2VL, which I am writing what? 2V. Easy thing. Now, this is E, this is 2V. It can produce a current like this. Definitely it can, a clockwise current. So in this setup, current will be clockwise. But let's wait. Let's identify this one. This is 2E. This is E. This is 2E and this is E. Look, which one is dominating? This one is dominating. 2E. E. This is dominating, and therefore current will be like this, which is also what? Clock. This we have already ruled out. It's not something which is possible. D is what? 2E and E, which is dominating. 2E. What is the sense it is producing? 2E is dominating, and therefore current will flow like this. But we know that current is what? Clock. And therefore option D is also not possible. So now the fight is between B and A. Some of you have written C also, D also. Now you can see that they are not correct. Note on this, I'm giving you another 30 seconds. So which one is correct, A or B? The final answer between A and B. Do you want to stick with your previous answer, or you want to change it? One of you has changed his answer. Others, do you want to stick with your answers? If you have written A and you want to stick with A, no issue, but if you want to change it, you can. Similarly, if you have written B but you want to change it from B to A, you can do that. we have found that C and D are something that's not possible at all. Look here. Look at both rods. Forget about flux. Forget about flux. Let's go for STP. That will give you a fast answer. And this comes with practice, which method should be used. There are two rods. They are moving in the same direction in the presence of same magnetic field. If I had not given you concept of flux and I had simply asked you, a rod is moving to the right in the presence of a magnetic field which is pointing in. There is another rod which is moving to the right in the presence of a magnetic field which is pointing in. Direction of induced EMF should be same or different. Then you would say that it should be same. Up, up. And therefore this is the correct one. Up, down, it's not the correct one. This is coming from STP. So only B option is correct. And it's a good thing some of you change your answers. And look at the analysis part also. Listen again. There are two rods moving in the same direction. If they are moving in the same direction, then as TP says, scalar double product technique, it says in both rods direction of EMF should be same. In both rods direction of induced EMF up, up. Overall this is dominating and therefore is giving us an anti-clockwise current. But in this you can see directions are opposite. This is coming from STP. Let's see whether flux approach can also help us or not. Let's find out this with the help of flux. Look at this rod. Keep this at rest for the time being. Let's decide direction of flux in this. EMF in this. If I keep this rod at rest, then as the rod moves in this direction, area is increasing. But second time, keep this rod at rest. As this rod moves in this direction, area is decreasing. So for this, area is increasing, for this area is decreasing, and therefore they are producing, their tendencies are to produce different sense of EMFs. Listen again, if you want to hold this rod at rest, start moving this rod in this direction, area of the loop is decreasing. If area of the loop is decreasing, then EMF will try to increase the flux. But if I keep this rod at rest and this one moves, then area of the loop is increasing and therefore induced EMF will try to decrease the flux. So they both are producing different directions of magnetic field. But this and this, these both batteries, their tendency is to produce same current. And therefore even flux approach says something like this is not possible. So the correct answer is what? B. And better method is use what? Concept of STP. So this is this comes with practice, in which question, which approach will be much easier This is something which you learn with practice. You can see both approaches are correct. Both flux and STB, they are producing the same answer, but it's about your practice level. And simply, if you wish, the STB part again, in the very basic STB part, there are electrons moving in this direction. In 5 seconds, if somebody needs to produce, there are electrons moving in this direction. Current will be in this direction. FBI, B is in, electrons are moving that way, current is in this direction, force will be downwards. Similarly, you can find over here, force will be downwards means this end will be negative, this end will be negative. So we have found what direction of current, direction of polarities of batteries, polarities of the batteries. Now you can see that this battery and this battery, the final setup, last 1 minute, final setup of this figure looks like this. And if somebody can write the current, do it fast. Everything is on the board. Final setup, you can show it like this. Either draw a separate figure or write down the same thing. R and R. Let me draw the whole thing again. A battery, a resistance. Resistance, battery. 2E, E, R, we need I. What is I? 2E minus E. This is being opposed by this. What is total resistance of the circuit? R plus R. This R and this R, they are in series. You have got same current flowing, which is the definition of what? Series. The same current is flowing, but this 2E is being opposed by this 2E minus E divided by 2R. For more detail, if you wish, you can see combinations of batteries. So your I is coming E divided by 2R. And what's the value of E? E is what? BVL. BVL divided by 2R. That's the current. So we have found current. Last part is what? Force. Very easy. You have the current. You have the current. Current is known. Magnetic field, length. Both rods are moving in same magnetic field. They have same current. They have same length. Theta is 90. So that's the force. VIL. VIL. For direction, you can see, just tell me in the comment box fast, last 1 minute, direction of force on these rods will be same or different. In this form, same or different. If you think same, write down same. If you think different, write down different. I have given you the magnitude. Magnitude will be same. Why? You have same magnitude, identical rods of same length, having same current I. So force is same. What about direction? They both are having same direction, or force is different in these. Write down this fast in the comment box. Same or different. The comments are coming same, same, same. Comments are same, same, same. And it's such a shame that we are saying same. Why? What is the direction of current? Down. What is the direction of current? Up. They both are moving in the same magnetic field, and therefore direction of force cannot be same. Now you thought that rod is moving in this direction, and so you told us this is the cause which should be opposed. You immediately applied force in this direction. But remember, this rod is trying to increase the area, but this rod is trying to decrease the area. This rod, hold this one, hold this thing. This rod is trying to decrease the area. Causes are different. Increase, decrease, and therefore directions of forces are also not same. Note down this much. Rest we'll see in the next class. Thank you very much.